right, so lesson 43. Lesson 43 is about finding the least common multiple. So let's talk about what that means. If we have something like 18, three numbers, 18, 81, and 500, and they ask us to find the least common multiple of those numbers, then the way that you would find the least common multiple is to think about these guys as prime factors. What do we mean by prime factors? Can someone tell me that? When I say break something down into its prime factors, what are we talking about?
Is it things that can't multiply to itself?
Yeah, so it's like if I wanted to break down the number 8 into prime factors, I would change it into 2 times 2 times 2, right? Let's break it down into its smallest numbers that aren't divisible by anything else except for itself and 1, right? So like in the case of 18, if I break down 18, that breaks down into, we know 18 is divisible by 2, right? 2 times 9 is 18. And then 9 you can break down into 3 times 3. So that would be 18 broken down into its prime factors. Everybody understand that? Makes sense? Let's do the same thing with 81. We know that 81 is 9 times 9. And then each 9 can break down into 3 times 3. So 81 is 3 times 3 times 3 times 3. Right? And then finally 500. 500 can be broken down into 5 times 100. 100 can be broken down into 10 times 10. And then 10 can be broken down into 2 times 5. So we could say 2 times 2 times 5 times 5 times 5 would be what we could break 500 down into. So those are the prime factors for each of those numbers. All right? Yep. Yeah, go ahead. So when we're finding the least common multiple, what we're doing is we're looking at the breakdown of these prime factors, and we're taking the max number of the prime factors in each one. All right, so like in the case of 18, there's 1, 2, and there's 3 3s. All right, so the max number here is 1, 2, and 2 3s, right? But over here, we have a total of 4 3s. And over here, we have 2 2s and 3 5s. All right, and so when I'm forming the least common multiple, I'm looking at each of these guys, and I'm grabbing the most of each of those prime factors that I can from each one. So which number here has the greatest number of 2's in its prime factors?
500.
500 does. So I'm going to grab these 2's because there's 2 of them there. And which number has the greatest number of 3's?
81.
81. So 81's got 4 3's, so I'm going to grab those 4 3's. And then the other prime factor we have is the 5. The only one that's got 5's is 500, and it has 3. So I'm going to grab those 5's. So when I ask for the least common multiple, I'm going to say it's 2 times 2. I grab the greatest number of 2's that I had, times 3 times 3 times 3 times 3, which was the greatest number of 3's I had in anything, times 5 times 5 times 5, which was the greatest number of 5's that I had in anything. And so when I multiply all of that together, I get 40,500. That's how we determine the least common multiple. Did that process make sense to everybody? All right, just to make sure that you guys followed me, let's see if you can help me do another one. We'll do 30 times 75 times 80, all right? 30 times 75 times 80. So we're going to get all of those down. 30, 75, 80. What are the factors of 30?
You could break it down into 2, make it 15, and then break it down into 5s. Or 3s, if you wanted to go smaller.
Okay, so 2 times 15 is 30, and 3 times 5 is 15, right?
Yeah.
So do you guys all agree this is 2 times 3 times 5? Right? All right, what about 75? Somebody else help me out with breaking down 75. Okay?
So it would go divided by 5, which would be
It's easier to divide it by 3 first.
3.
What would 75 divided by 3 be?
25.
Yeah, right? And what's 25?
25 would, then you go down.
To what?
5.
Just 5 times 5, right? So if we divided it by 3, we see that it's 3 times 25, and 25 is 5 times 5. So you definitely could do the way that Cohen started it, and say, let's divide it by 5 first, because we know 75 is divided by 5, but that's going to be harder to do in our heads. I'm going to have to pull out the calculator too, because I don't know what 75 is divided by 5. I know by looking at this that 75 divided by 5 is going to be 15, now that I've broken it down. And then you could break the 15 down into 3 and 5, all right? But does everybody, are you guys all getting how we get down to these numbers? You're seeing how we're doing that? I don't want to lose anybody in that process. Like I could draw steps in the middle here, right? I could say 30 is the same as 6 times 5, and then I break down 6 into 2 times 3. I can think about it like that. But as long as you guys are okay with us just doing that in our head, then I'll just keep doing it that way. I just want to make sure you follow me. And then finally 80. Somebody else want to take a stab at breaking 80 down for me? Somebody that's not on the board, maybe? Okay, Alexa?
It can be divided by 5, which is 16.
5 is 16. She chose the hard one. I would have chosen 2 because I'm not that smart. So 5 times 16, okay. And then 16 breaks down into, the obvious is 4 times 4. And then each of those 4s break down into 2 times 2, right? So that should mean that 2 times 2 times 2 times 2 times 5 is 80. So let's just, like I said, I would have broken it down by 2, which would have given me 40. And then 40 breaks down into 8 times 5. And then 8 breaks down into 2 times 2 times 2. So yes, so that should be right. However you want to think about breaking it down is fine. Just make sure you get to the correct prime factor. And what am I going to do probably to just verify I got this right? I'm probably going to punch it in on my calculator to make sure, right? You could do a factor tree if you wanted to. You could say 8 is 2 times 40, and then break that down into 8 times 5, and then break that down into 4 times 2, and then break that down into 2 times 2. And so then whatever's at the end of your nodes here, as you create your tree, that would be your prime factors. Yep.
Can I get that?
Yeah. So if you need to take that step, definitely do that, right? So I want to make sure that you get it all. So just our prime numbers, if we think about the prime numbers that are in all of these prime factors, what are the prime numbers that are involved? That are unique prime numbers. For example, 7 is a prime number, but is 7 in any of these factors? No. So which are the prime numbers that are in these factors? There's only 3. 5, 3, and 2. Right? You guys see that? So we're looking for the most number of those when we're creating our least common multiple in each of the factors. So where are our most 2's?
Under 80.
Under 80. We've got 4 of them, so we got to put 4 of those down. Right? Where are our most 3's? 30 or 75, right? There's only 1. And where are our most 5's?
75.
75. So we got to do 5 times 5. There's 2 5's there, right? So that's how we get our least common multiple for that one. And when we multiply all that out, again, I'm not going to be able to do it in my head. I'd break out my calculator too. It's going to be 1200. All right? I could do it in my head, but it would be painful. All right. Any questions about least common multiple? Why do we need to know about the least common multiple? That's what the whole reason that we're doing this is because of this next step, which is where you're going to see the importance of knowing the least common multiple. Actually here, in this one, it's actually, I guess, in the next chapter where we see it coming together. So here we're gonna, now that we've dealt with numbers, we're gonna try and introduce variables, right? Because after all, this is algebra. And algebra is all about using variables. If you think about an algebraic expression, that's generally what comes to mind, is having variables in there. So what if you had something like this? What if your terms were 15a squared b and 10ab cubed? What's that?
No.
I was like, is this when you're like, okay, I'm checking out, I'm done. We're going to put variables in here? No way. No way. So let's break these guys down into prime factors. All right? What would my prime factors be for 15a squared b? Somebody not on the board want to take a stab at it?
5 times 5 times.
5 times 5?
Wait, no, I'm sorry, that's wrong.
What's
5 times 3.
Yeah, so I'm going to put the 3 in the front. 3 times 5, all right? And then how do we break down those variables?
A
Yeah?
to the exponent of 1.
We don't put the exponent in there, we're breaking it down into its smallest. Yeah, so a to the 1, but we don't write the 1, okay?
And then another one.
Another a, right?
And then B.
Times b. Make sense, everybody? Does everybody see how that's how you would break that one down? And then what about the last one? Someone else want to give it a shot? This is the easy way to get your name on the board. Yes?
Would it be 2 times 5? And then A, B, B, B.
That's it? Exactly. Excellent. All right, so even though we have variables in there, our process is exactly the same, right? We break it down into its smallest prime factors. For variables, that means we break it down into a single variable to the power of 1. And then we look at each one. So what are our prime values that we're going to include in our least common multiple for this one? We're including if we look at just the individual possible values, we can have a 2, a 3, a 5, an A, and a B. You guys see that? So we've got to look at our terms and see which one has the most of all those. The most 2's, it's just going to be 1 that's in this one over here, right? The most 3's, it's just going to be 1 that's in this term over here to the left. The most 5, both the left and the right term only has 1 5, so it's just going to be 1 5. What about the most A's? Like you were gonna say, I just drew a blank and wanted to call you Allison. Hang on, don't tell me. Oh, I didn't. Did I take roll? I did. All right, but I'll use the roll to cheat. I'm sorry, Kirsten. So what would it be? What are the most A's that we have?
15.
Right here, right? We have 2 A's, so we need to write down 2 A's there. And then finally, the most B's we have are in the right-hand term, and we've got 3 of those guys. So we need to write down 3. Uh-huh.
How come you'd only write 1 of the 5? Just because there's 1 in each?
That's right. The most we have in either one is 1. So it's the biggest number that we have of 5's in all the terms, and the most we have is 1. Okay? And so then we just multiply that together, and that'll be our least common multiple. 2 times 3 is 6, times 5 is 30. So our number is 30. A times A is A squared, and B times B times B is B cubed. So that would be our least common multiple when we're including variables in the mix. Any questions about that? No? Now we're going to see why it's important. Okay, this is why we needed to know how to do this, and it's in lesson 44 is where it comes into play. But before we see how to use this in lesson 44, let's just make sure we can recognize like terms when we've got fractions in the mix. Okay, so when we've got variables in our fractions, and we're trying to determine, can I add terms together? What's the rule? What's the rule if I have something like this? Which of those two, the top or the bottom one, can I just immediately add together?
The bottom.
The one at the bottom. Why?
Because it has the same denominator.
Because they have the same denominator, right? So we already know with working with fractions that you've got to get the denominators to be the same value before you can add them together, right? So this becomes 6/5. All right? Now, we learned a trick for being able to add them together like this. And the trick that we learned was least common multiples, right? We said, what is the least common multiple for 4 and 3? And we know that 4 breaks down into 2 times 2, and 3 just breaks down into 3 times 1, so we can just write the 3. So the most number of 2's in it is the 2 times 2 and the 4. The most number of 3's is the 3 times 1 and the 3. And so when we multiply all that together, 2 times 2 is 4, times 3 is 12. The least common multiple for 4 and 3 are 12. And so that's the denominator that we want to get for our fractions, right? So we change these to have a denominator of 12. How do we do that? How do I change 3/4 to have a denominator of 12?
Multiply by 3.
Multiply top and bottom by 3, right? So 3 times 3. And how do I change 2/3 to have a denominator of 12?
Same
Multiply
thing.
by 4.
Multiply top and bottom by 4, right? 4 times 4 is 2 over 3. Did I spell that right? Okay. So when we do that, on the top we get 9 over 12, and I'm sorry, that was the top of that one, but that was that term, and for this term we get 8 over 12, and so then we can combine them together and say our answer is 17 over 12, okay? We've already used least common multiples before when we've worked with fractions, but now we're going to introduce that idea using variables. It's the same basic idea, okay? So we can only add fractions together once the denominators are the same. So that means if we have a problem like this, if we have 4 over 2x squared plus y minus 6ax over 2x squared plus y, right? Because those guys have the same denominator, that means we can add them together, right? Even though it's got variables in it, since the expression is exactly the same in the denominator of this one as it is in the denominator of this one, then we can add those two together. And so what do we do when we add them together? We only add the numerators. We just keep the denominator that's there, right? So when we add this together, we have a 2x squared plus y on the bottom. That stays the same. But what we actually add together is the 4 and the 6ax. And since there's a minus in between, we actually are doing subtraction here. So 4 minus 6ax is what we would have in our numerator. Does everybody see that? It's the same exact thing that we did right here. It's just that we had variables in the mix, but we're doing the same operation, okay? So what if we had something like this? What if we had 5x plus 7 divided by 5a squared x minus 3x minus 2 over 5a squared x. Can I add those together? Can I add those fractions?
Yeah.
They have the same denominator, so I can, right? So what would it be? I know the bottom is going to be 5a squared x. What is the top going to be? Anybody walk me through that?
You combine the 5x and the 3x together?
Yep. So here's what I'm going to do. I'm going to just first write all this down because I've got this minus sign in the middle here. I don't want to get it confused with my signs. So I'm going to do this. I'm going to do 5x plus 7 minus, and I'm going to put this whole thing in parentheses here so I can keep track of my signs. Okay? It's just to keep me from making a mistake there. Now let's combine our like terms in the numerator. All right, so same thing here, 5a squared x on the bottom. So I've got a 5x minus 3x, right? So that's 2x. And I've got a 7 minus a negative 2, which is going to be a 7 plus 2. And so that becomes plus 9. Does everybody see that? So that's how we would combine them together. Now, what if I don't have the same denominators and I've got variables involved? So what if I have something like this, 3/4 plus 2 over b? This is where we're going to use least common multiples, the same way that we did here. We figured out that the least common multiple of 4 and 3 is 12. What would the least common multiple be of 4 and b?
4b.
Just be 4b, right? So what I've got to do is I've got to get some final answer that is something over, everything over 4b, right? That's what I'm trying to do. So I've got to convert this thing, both of these guys, to have 4b on the bottom. And the way that I do that is just like we did it with the fractions, right? I multiply this one, since this is missing a b, I'm going to multiply this term times b on the top and the bottom. So it becomes 3b over 4b. I multiply top and bottom by b to get that. All right? And our second term, we need 4b on the bottom, so what am I going to multiply this term top and bottom by? I need 4b to be on the bottom.
So 4.
So I'm multiplying top and bottom by 4, right? So 4 times 2 is 8 over 4b. Does everybody see that? And so then I can combine it together and just write it all over 4b and say our final answer is 3b plus 8. Okay? One more example and I'll let you go. We're just going to get through 44 today. And this one is P over 4 minus A over 2 plus C over B. All right? What's my least common multiple for my numerator? I have a 4, a 2, and a B. 4 breaks down into 2 times 2. 2 just breaks down into 2, and B breaks down into B. So what's my least common multiple going to be?
8b.
What'd you say?
8b.
It's not. Because remember how we did least common multiples? We looked at the max number of each of those guys. So the max 2's that we have in any one is 2 2's, right? So this would be a 2 times 2, and the max B that we have is that. So it would actually be 4B. So you were close. Close enough to get your name on the board. Do you guys see why it would be that? All right, and so now I can turn each of these guys into 4b, right? By saying this term here, I'm going to multiply top and bottom times b. This term here, I'm going to multiply top and bottom. If it's got a 2, what do I need to multiply it by to get 4b? What do I multiply 2 times to get 4b? 2b, right? Is it 2b or not 2b? It's 2b, yeah, okay. 2b on top and bottom, that's a times 2, plus, and then b, I'm going to multiply it by 4 to get 4b. So I multiply top and bottom times 4. So then when I do all of that, I get bp over 4b minus 2b times a is 2ab over 4b, plus 4 times c is 4c over 4b. And so then I can put all of that over the same denominator, 4b, and I have bp minus 2ab plus 4c on the top. All right? Any final questions? What are we having next week? A test in class. So here's what we're going to do, all right? I'm going to reserve like the first 20 minutes of class for answering your questions. So if you've got anything that you struggled with on the homework this week, which is just 2 lessons, let me know. The test is going to cover all the way through lesson 44, okay? Thank you, buddy.